Hello everyone, welcome to the course of Computer Network. In this video, we will see analog to analog conversion. Why there is a need of analog to analog conversion. Analog to analog conversion is the representation of analog information by an analog signals. मतलब क्या कर रहे हैं हम लोग एनालॉग इंफॉर्मेशन को रिप्रेजेंट कर रहे हैं एनालॉग सिग्नल के फॉर्मेट. One may ask why we need to modulate an analog signal. It is already analog. So why we need to do analog to analog conversion? So modulation is needed if the medium is band pass in nature or if only a band pass channel is available to us. So ये बात ध्यान में रखना है. Why we are needed band pass analog to analog conversion? Because in order to if we have a band pass channel, so we need to do analog to analog conversion. So, इसकी एग्जांपल हम लोग ले सकते हैं रेडियो की. फॉर एग्जांपल वी हैव रेडियो. The government assigns a narrow bandwidth to each radio station. मीन्स क्या हो जाएगा, each रेडियो स्टेशन के पास क्या रहेगा, रेडियो स्टेशन के पास somewhat narrow bandwidth. Okay. The analog signal produced by each station is low pass signal. तो इस केस में क्या होगा, जो एनालॉग सिग्नल होगा वो क्या रहेगा, लो पास सिग्नल रहेगा. And all of the same range. Low pass signal with same range. To to be able to listen to different stations, if you want to listen different stations, the low pass signal need to be shifted. So in that case, low pass signals it need to be shifted. Each at different range. Okay, so that's why we are required analog to analog conversion. So what are the techniques that are used for analog to analog conversion? First is we can say that amplitude modulation, frequency modulation, and phase modulation. So these are the technique we will see for the analog to analog conversion. We will see all the techniques in detail. So according to this diagram, we can remember these techniques easily. Analog to analog conversion. First we have amplitude modulation, FM frequency modulation, and PM phase modulation. So let's see what is amplitude modulation. A carrier signal is modulated only in amplitude value. जब भी कैरियर सिग्नल ओनली एम्पलीट्यूड वैल्यू पे मॉडिफाई होगा तो हम लोग क्या करेंगे, वहां पे एम्पलीट्यूड मॉड्यूलेशन यूज करेंगे. द मॉड्यूलेटिंग सिग्नल इज द इन्वेलप ऑफ द कैरियर. सो इट विल क्या करेगा, एनवेलप करेगा कैरियर को. द रिक्वायर्ड बैंडविड्थ इज 2b, where b is the bandwidth of the modulating signal. So 2 into bandwidth of the modulating signal will be the required bandwidth. Since on both sides of the carrier frequency, we are showing it as like Fc, the spectrum is identical, so we can discard one half, thus requiring a small bandwidth of transmission. So we can see in the diagram, amplitude modeling is normally implemented by using simply a multiplier. So here we are using simple multiplier because the amplitude of the carrier signal needs to be changed according to the amplitude of the modulating signal. So here this will be the signal that is used for modulating. This is the carrier frequency, and then the modulated signal will look like this. So this is the amplitude modulation techniques. The total, as we said, the total bandwidth required for amplitude modulation is 2 into bandwidth of the channel. So BAM is equals to 2B. AM band allocation. AM stations are allowed carrier frequency between 530 kHz to 700 kHz. Each station carries frequency must be separated from those on the either side of it by at least 10 kHz. That is 1 AM bandwidth to avoid interference. If one station uses a carrier frequency 1100 kHz, the next station carrier frequency cannot be lower than 1110 kHz. That we have to remember. Next technique is frequency modulation. The modulating signal changes the frequency Fc of the carrier signal. Here which we are modulating using frequency. The bandwidth for FM is high. It is approximate 10x the original frequency. 10 times of original frequency का होता है. The total bandwidth required for FM can be determined from the bandwidth of the audio signal. BFM is equals to T 1 plus beta into B, where beta is usually 4. And beta is a factor that depends on modulation technique. That depends on what? Modulation technique. Which modulation technique you are using. And the common value, as I said, is 4. The frequency modulation. We can see the bandwidth of FM signal. Here, amplitude signal, that is audio, this will be the carrier frequency, and the FM signal will be this. The actual bandwidth is difficult to determine exactly, but it can be shown empirically, that is several times the analog signal. Okay. So the bandwidth of audio, here we are using voltage controlled oscillator for converting signal, analog information to analog signal. Here the FM band allocation. The bandwidth of audio signal broadcast in stereo is almost 15 kilohertz. The FCC allows 200 kilohertz for each station. Station must be we have FM stations are allowed to have carrier frequency between 18 megahertz to 108 megahertz. Station must be separated by 200 kilohertz to keep their bandwidth from overlapping. To create even more privacy, the FCC requires that in a given area only alternate bandwidth allocation may be used. The other remain unused. So here if we are using this, this will be have to be not used. Given 88 to 108 megahertz as a range, there are 100 potential PM bandwidth in the area, of which 50 can operate at any time. So in this figure we can see that. Next is phase modulation. The modulating signal only changes the phase of the carrier signal. Here the modulating signal will be used to change the phase of the carrier signal. The phase change manifests itself as a frequency change, but an instantaneous frequency change is proportional to the derivative of the amplitude. The bandwidth is higher than amplitude modulation. This is the signal. Modulating signal is this carrier frequency and PM signal. PM is normally implemented by voltage controlled oscillator VCO along with derivative d by dt. The frequency of the oscillator changes according to the derivative of input voltage, which is amplitude of the modulating signal. The total bandwidth required for PM, that is phase modulation, can be determined from the bandwidth and maximum amplitude of modulating signal. So the formula will be 2 plus 1 plus beta B, and B most often. Here B is most often. So this is all about PM bandwidth, PM, that is phase modulation. Thank you.